Okay, let's do an example for finding a linear approximation, which is the same as saying find a tangent plane at a point for the following function. So let's say that f of xy is sine of x cosine of y, and we want to approximate f of, say, 1/2, 1/3. Okay, and just being pragmatic, we'll say, well, that's pretty close to 0, and so we do understand the value of the function at 0, so x0 and y0 will be 0, 0. And then we'll write f of x, y in terms of f of x0, y0, and the derivatives. So remember, I wrote the formula here, but I can write it one more time. In general, this is approximated by the function at the reference point, the value of the function at the reference point, plus the partial derivative of x evaluated at the reference point times x minus x0, plus the partial derivative of y evaluated at the reference point times y minus y0. Okay? And so again, this is f of x0, y0 is 0, is it's just sine of 0 times cosine of 0, which is a 0. Then you take the partial derivative of f with respect to x. That's just cosine of x cosine of y. Okay, and so that partial derivative evaluated at the origin, which is our reference point, is cosine of 0 times cosine of 0, which is just 1. On the other hand, the partial derivative of f with respect to y is sine of x minus sine of x sine of y, and this one evaluated at the origin, right, is sine 0 sine 0, so that's 0. Okay, so if you follow the formula for finding the value at 1/2, 1/3, so f of 1/2, 1/3 is approximated by f of 0, 0, which is 0, plus the partial derivative of x evaluated at the origin, which is 1, times x minus 1/2, times, it's a number. So here x is like 1/2. In this case, x is 1/2, y is 1/3 in the formula. So it's 1/2 minus 0 plus the partial derivative with respect to y at the origin, which is 0, times 1/3 minus 0. And this is very simple. Everything goes out, cancels, except this term, which just gives you 1/2. Okay, and this is how the Taylor approximation works.